Let's take a look at volume of a pyramid. Before we do, let's review how to find the volume of a rectangular prism. So a rectangular prism is a 3D object which has 6 faces that are rectangles, and they meet at right angles, so the faces are perpendicular to one another. And to find the volume of the rectangular prism, we take the length of the prism, we multiply it by the width, and we multiply it by the height. A shortened way to write that is volume equals base times height, but notice this time the B is a capital B, whereas when we're doing like area of a shape, we use a lowercase b. That capital B represents the area of the base. So if your base is a rectangle, you find the area of that rectangle and then you multiply it by the height. Rectangular prisms are important because they are related to pyramids. So in class, we're going to watch a video that shows you how the volume of a pyramid is related to the volume of a prism. But let's make sure we understand what a pyramid is first before we get into how to find the volume. So with a pyramid, it's also 3D. Everything we're doing in this unit is three-dimensional. It is formed by some sort of polygon base. In this class, we're going to look at where the base is a square, a rectangle, or a triangle, but it could be any polygon. It could be a pentagon, it could be a hexagon, an octagon, it could be anything, but we're going to do square, rectangular, or triangular. And then the base, the edges of the base are connected to what's called the apex. And so it has triangular faces on it. So in the square pyramid on the left, we have a square base. So all of these sides are the same. And then there are 4 triangles that are connecting the base of the square to the apex. In a rectangular pyramid, very similar, except for the base is a rectangle. So your triangular faces are all going to be, they're not all going to be different, but you're going to have 2 different triangular faces. So the 2 on the side are going to be the same, and the 2 in the front and the back are going to be the same. And then you have a triangular pyramid where the base is a triangle and then the faces that connect to the apex are also triangular. Depending on the specific type of base, whether it's equilateral or isosceles or scalene, you might have some of these triangular faces being congruent, or they could all be completely different. So in class, we're going to watch this video right here that's going to show you how the volume of a pyramid relates to a prism. But essentially, if you take a pyramid and a prism that have the same exact base, and you fill up your pyramid, let's just say with water, I think that's what they do in the video, and you pour it into the prism, it will take 3 pyramids to equal 1 prism. So the volume of a pyramid is equivalent to the base times height, like a prism, but then divided by 3. B, that capital B, the way that you write your letters is really important. That's a capital B. That means the area of the base. So if your base is a square, you will find the area of the square and then multiply by the height. If your base is a rectangle, you'll find the area of the rectangle and then multiply by the height. And then if your base is a triangle, you'll find the area of the triangle and then multiply by the height. Remember that height must be perpendicular. So that's really important that you're using the perpendicular height. You're not using something like the slant height in the previous slide. So let's just work through a few examples. So we're going to find the volume of this pyramid. It is a rectangular pyramid because the base is a rectangle. So our formula is base times height over 3. So I'm going to look at the base. I'm just going to draw it out separately. You definitely don't have to do this. It's 21 by 9. It's a rectangle. To find the area of the base, we do length times width, or base times height, which would be 21 times 9. And 21 times 9 is 189. So B, the area of the base, is 189. The height of the pyramid has to be perpendicular to the apex. So if you're looking at this picture, you can see this dashed line on the inside, and it is definitely perpendicular to the base because you can see that perpendicular symbol. So the height of this pyramid is 5. So to find our volume, we're going to do 189 times 5, and then we're going to take that answer and divide by 3. So that would be 315. In the previous unit, we talked about making sure that we add units when possible. So we are using yards in this one, and volume is measured in yards cubed. So yards cubed. Area would be units squared, and just length is regular units, but volume is always cubed. In our second example, we have a triangular prism. So I'm going to draw that base out. We can see that one side is 12. We've got a dashed line in the middle with a perpendicular sign, so that's representing the height of that triangle is 7.5. So the first thing I'm going to do is I'm going to find the area of that base. So the area of a triangle is given to us by base times height over 2. Notice here I'm using a little b because a little b is representing just the actual base length, whereas big B is representing the base area. So the base length of the triangle is 12. The height of the triangle is 7.5, and then again we're dividing that by 2. So we're going to take 12, multiply it by 7.5, and divide by 2. And that will give us a base area of 45. So the volume equals 45 times, let's look for the height. Again, when we're looking at the height, we want to make sure that it's perpendicular. So we can see right in the middle, we've got this dashed line, it's got the perpendicular sign, and it is 10. So the height of this pyramid is 10. So if we do 45 times 10 and then divide by 3, we will get our volume. So our volume should be 150. Our unit is millimeters, and because it's volume, we're going to cube it. All right, on example 3, we have another triangular pyramid because our base is a triangle. So I'm going to start by drawing that base out. Notice we've got a right angle in that back corner. We have that this side is 14 and the hypotenuse is 22.1. All right, so how do we find volume of a pyramid? Well, we need to figure out the area of the base, then we need to multiply it by the height, and then we're going to divide by 3. So when you have a triangle, you take the length of the base, multiply it by the height, and divide by 2. Remember that base and height have to be perpendicular. So that 22.1 is not the base and it's not the height, that's the hypotenuse. In a right triangle, the legs are the base and the height. So I know that one of my sides, and you can call it base or height, it doesn't matter, I'm just going to put it in for base, is 14, but right now I don't know the height of that triangle. So how do we find a missing side of a right triangle? Well, we can use the Pythagorean theorem. I'm going to label it h for height, and I'm going to set this up as h squared plus 14 squared equals 22.1 squared. So 14 squared is 196. 22.1 squared is 488.41. We're going to subtract 196 from 488.41. which is going to be 292.41, and then we're going to take the square root. And that actually works out nicely to 17.1. So we just figured out the height of the base is 17.1. So to find the area, I'm going to do 14 times 17.1 and then take that answer and divide by 2. So our base area is going to be 119.7. The height of the pyramid, remember it must be perpendicular, so we do have coming down from the apex, we've got that dashed line, it's got the perpendicular symbol on it, and we have that length is 19, so the height of our pyramid is 19. So to find the volume, we take our base area of 119.7, we multiply it to our height, and then we take that answer and divide by 3, which should give us a volume of 758.1, and we're in meters cubed. All right. Now we're looking at a square pyramid. So again, the base doesn't change the formula for volume. Or as long as it's a pyramid, we're doing base times height over 3. What does change is how we find the area of the base. So since we have a square, to find the area of the base, we just do, you can do base times height, or you can do side squared. So we're going to do 14 times 14, or 14 squared, which is 196. So the area of our square base is 196. Then we need to determine the height of the pyramid. So when we're looking for the height of the pyramid, we are trying to find the apex, and it's got to be perpendicular to the base. We do not have that measurement. We do not know the height of our pyramid. What they gave us was 25, which is the slant height of the pyramid. If we connect our height of the pyramid to the base of the pyramid, we actually create this right triangle in here. So I'm going to kind of draw this right triangle out a little bit. Let me highlight it so you can see a little bit. So here's the height, we connected it, and then here's the slant height. So that triangle right there is going to be a right triangle. We don't know the height. We know the slant height is 25, and then we can determine that other leg because it's a square, the length is going to get cut in half, which is going to make it 7. So how can we find the height of the pyramid? We can use Pythagorean theorem. So h squared plus 7 squared equals 25 squared. So we know that gives us 49. 25 squared is 625. We're going to do 625 minus 49, which is 576. And then we're going to take the square root of 576, and that is going to tell us the height of our pyramid, which will be 24. So to find the volume, we're going to take the area of the base, which was 196, the height of the pyramid, which we just found was 24. We'll multiply this together, and then we're going to divide by 3. So our volume is going to be 1,568 feet cubed. This one, although finding the area of the base was pretty easy, we did have to do a little bit more work to find the height of the actual pyramid. All right, in the last one of these straightforward questions, we're going to do a word problem in just a minute, but in the last just basic finding the volume of a pyramid, we have another triangular pyramid. And the base, we can see right here is this triangle. I'm going to draw that off to the side. We know the left and the right side are 10, and we know that the back side is 10. So this is actually an equilateral triangle. So to find the area of the base, I need to do the base of the triangle times the height of the triangle and then divide that by 2. Remember that base and height must be perpendicular, and in that equilateral triangle there is nothing that's perpendicular, but you can add something that's perpendicular. So I'm going to add a little dashed line. That's going to be perpendicular. That line right there will be the height of the triangle. Even though it's like upside down, it's still the height because it's perpendicular to the side. I could have drawn the height a couple of different ways. That was just the easiest way for me to draw it. When you draw the height, what it does is it splits that side to 5 and 5. And so now we're looking for the height of the triangle. So I want you to focus on just one side of the triangle. It can be the left or the right. I'm just going to highlight it right here. That is a right triangle, which means we can use the Pythagorean theorem to find the height. So h squared plus 5 squared, those are the two legs. 10 is the hypotenuse. 5 squared is 25. 10 squared is 100. If I subtract 5, I'm going to get 75. And if I square root 75, I am going to get 5 root 3. And you can go ahead and leave it as 5 root 3, or you can turn it to a decimal. It's really up to you at this point. I do prefer to leave this type of scenario in exact form, so I'm going to leave it as h equals 5 root 3 instead of rounding. I'll save rounding to the very end. So now that we have the height of the triangle, we can find the area of the base by doing the base, which was 10, times the height, which we just found was 5 root 3, over 2. So that would be 50 root 3 over 2, which is 25 root 3. All right, so a lot of work on this one up front to find the area of the base. But now that we have the area of the base to find the volume, we take that area of the base, which is 25 root 3, we multiply it by the height of the pyramid. Again, the height of the pyramid must be perpendicular to the base. So if we are looking at the dashed line, you can see right here, it's perpendicular to the base. So that 16 is the height. So we're going to do 25 root 3 times 16 and then over 3, not 2. And then from there, you can use your calculator. You're definitely going to get a decimal on this one because of the root 3, and we'll just round that to the tens place like we've been doing and everything else. So 25 root 3 times 16 and then over 3. So it should be approximately 230.9, and our unit is centimeters cubed. For the last problem, we have a square pyramid. It says Caitlin must build a sandcastle in the form of a square pyramid for a project, as shown below. She bought 3 bags of sand, each containing 1,200 cubic inches of sand. Will she have enough sand to build the castle? Okay, so in order to figure out if she has enough sand, we need to first figure out the volume of the castle. So again, because the castle is in the shape of a pyramid, we will do base times height over 3. The base of this one is a square, so finding the base this time should be pretty simple. All right, we've got a square and the sides are 25, so 25 squared, or 25 times 25, is going to be your base, which is going to be 625. For the height, we need to make sure we have the perpendicular height, which we do. We can see that coming from the apex down, and we can see that perpendicular symbol. So we know that the height of the pyramid is 18, and then divided by 3. So we're going to do 625 times 18 and divide by 3, and that will give us a volume of 3,750 inches cubed. Now she is buying 3 bags of sand at 1,200 inches cubed a piece. So for the sand, 3 bags times 1,200 is going to give us 3,600 inches cubed. So the sand will only be 3,600 inches cubed, and she needs 3,750 inches cubed. So no, she will not have enough. She's going to be short just a little bit, but she's definitely not, it's not going to fill it up. So no, she will be short 150 inches cubed. So essentially, she would need another bag of sand, and then she'd have more than enough.